And I am live. That is pretty cool. Today is 8th of October 2025, Wednesday, and we will just solve questions, right? At least 4 questions, and the interface for this thing has changed. That is kind of crazy cool. Shit, I cannot even see how many people are live watching, and that is okay. I can at least see the chat. Okay, cool. So CP31 and the stopwatch, and let's kill tmux, set tmux, and attach tmux. Go to the 1600 rated section. And also yesterday we were unable to do this problem meet on the line, but I did this afterwards, and yeah, I was messing up floats. The only problem in these submissions before was the float problem, and I think it is because here, look at this, when we are calculating the answer. Okay, I think this is the correct one. No, this gave the wrong answer. Mhm. And the correct one uses some variation of this. I was trying out different things: left, int, right, float. Make this float and set precision 10. That was the thing. Not double, but float and set precision to 10. And that helps to find the correct precision for this value. Right. Today we will do 4. All right. Today we will actually do 4. Hello. Which college? Tier 3 college near my house. And QWERTY. That is a very nice name. Split into 2 sets. It feels like uh, this feels like a question from CACS. Dynamic programming, I think. Split into 2. Yes. 2 sets. Part 2. Nope. 2 sets. These might be the same questions. 2 sets, 2 sets. Right. Cool. Let's do this one with the stopwatch on. Yes, I will keep at it. And let's grow together and become as good as we can, and then better than that. All right, cool. Stopwatch. Cool. Polycarp was recently given a set of n numbers, n even, n is even, dominoes. Each domino contains 2 integers, 1 to n. Each domino contains 2 integers. Okay. Can he divide all the dominoes into 2 sets so that all the numbers on the dominoes of each set are different? Each domino must go into exactly one of the sets. For example, if he has 4 dominoes in this, and this, then okay, these are the 4 dominoes. He has n numbers, n dominoes. Each domino contains 2 integers from 1 to n. Can he divide all dominoes into 2 sets so that all the numbers on the dominoes of each set are different? Each domino must go into exactly one of the set. For example, if he has 4, this is dynamic programming, then Polycarp will be able to divide them into 2 sets in the required way. The first set can include the first 3 first and third dominoes, all them. Okay, okay, and we just have to say yes or no. We just have to say yes or no. We just have to say yes or no. For each domino, we have the choice to add this domino on the left set or to add this domino on the right set, right? In the first set or in the second set, I have right now. I will watch you in 1 hour. Okay, cool. Yes, that is totally up to you. We have number n, and then we have pairs AI and BI like this. And we have to see if these are divisible. So with each domino, we have two choices. Yes, yes, we are not joking here. We actually want to get this correct as fast as we can, as if we are in a contest. All right, these are the dominoes. For each domino, we have choices where to put them. Let's say we have two buckets. Okay, let's first define how an optimal solution would look like. Yes, first step in optimal solution, if it does exist, then from set A, yeah, and we will suppose that these two sets, this is called set A and this one is called set B, right? This is set A and B, and we will say from set A in optimal solution, from set A, we can remove a element and still the answer would be valid. Yes. So if we have a valid answer, we can remove one of the elements from any of the sets, and the answer, what we are left with, that would still be valid. And how does the final optimal, or not just optimal, the final valid answer depends on some of the subproblems. It is if, yes, from this fact, we can see if we have a domino which is not in any of the set, then if we cannot add that domino to any of the sets, if we cannot add that domino to any of the sets, then yes, if we cannot add that domino to any of the sets, set A and B as we are calling them, then does the answer exist? Then it must mean that there is some domino in both of the sets which has a number which is also in this new set, new domino which we are trying to add into the sets, and those two which are in separate sets, they cannot belong to the same set, and that is why they are in different sets. Then no valid answer exists. So we just have to ask, is there a valid answer for this many dominoes? And if there is, which set can I add this domino to one of the sets? Yeah, that is nice. So we can have our DPI, which would tell us is valid for the first I configurations. And for the first I dominoes would be nice. Is there a valid solution for the first I dominoes? And after that, hello, stopwatch, but it is only till 50 minutes. Bro, we sometimes go up to 2 hours. That is crazy. But yeah. And okay. And yes, today I have come with the mindset of actually solving 4 questions at 1600 rating. That would be nice. So DP is valid for dominoes, and if it is valid, then I would like to know which domino can I add to which, yeah, to which domino, to which can I add this current I plus 1th domino to any of the sets. And to do that, I would need two bit sets or a Boolean vector, which would like quickly indicate which elements are there in one domino and which have not been added. Okay, cool. Think we do have the theory. Take an int vector int, let's use pair or a size n, and pair int initially nothing for int I equal 0, I less than n, I plus plus cn. Or what we can do if we were being a bit smart, or to reference x comma y from a cn x cn y. Cool. And now we have everything, and we need two Boolean vectors of visited a or va size n plus 1 and vb visited b size n plus 1. And now we will also have our vector Boolean, and which is like our dp state when we are considering the first n plus 1 I elements. Yeah, dp means valid configuration exists for the first I elements. Cool. And after that, if we know it does exist, also we will keep a Boolean response initially equals, let's suppose, true, and dp 0 equals true. I think that much initialization is cool. For int I equals 1, I less than equal to n I plus plus. Now we are at an element I. We need to know if the last state was true, if dp I minus 1. If the last state was true, only then we can do this. Otherwise, else res equals false and break. Because if a valid configuration does not exist for dp I minus 1, adding new elements is not going to help. Okay, so if a valid state does exist, we need to see which group to add. Wait, shit, if I can add this current element to any of the groups. Shit, if I can add this current element to any of the groups, I do not know which group to add this to. Mic issue, noise coming also your keyboard, although it feels ASMR. Shit, nice. Voice isolation is on. How? Hello. Is it better? I think now it is better. It should be better now. Yep. Yep. It should be better now, I think. Yeah, good now. Okay, cool. Shit, thank you for pointing that out. And keyboard is kind of cool. ASMR. Shit, if we can add the current domino to any of the sets, we need to know which sets. we need something more than a simple vector. I think recursion would be better. Here, n is big, ai and vi, but this is the case, and we do not want to have n square data, a visited state. That would be too much. He said this DPI is valid for the first I dominoes. Now, if it is valid, we need to know which set to add this one, this current one to. And there are only two sets. There are only two sets. So to know if I can add this current domino to one of the sets, we have the current values, and we also need from each of the sets which have been set A and B, what are the elements or dominoes which are in those sets, for which we can use a set to represent that, but we do not want to store two sets. Like, it wouldn't even work. Yes. And these dominoes have two numbers. So first of all, if I ever see that there is some number that is appearing three times in three different dominoes, then answer would be no. And another thing would be this one is going to go into different groups, right? This one is going to go into different groups, and therefore this 3 and 1, this 3 and 4 are also going to go into different groups, and this 3 would go into the same group as this 1 and 4. And then we see this 4 and 2, which will go in the same group as 1 and 3. Each domino contains one numbers. Can he divide all the dominoes into two sets? Answer is no here, because have we have 8 only two times, 6 also only two times, 4 also only two times, 5 also only two times, 3 is also only two times, 2 is also 1, and 7, everything is only two times. There, wait, are all the numbers appearing only two times? Wait, shit, this is a graph question. Split into two sets. Can each domino contains even and even dominoes? Each domino contains two integers from 1 to n. Can he divide all dominoes into two sets so that all the numbers on the dominoes of each set are, each domino must go into exactly one of the two sets? For example, if domino is this and this, the next n lines compare this, describing the numbers on the ith domino. And we only, if you only have two copies of each domino, then this is a graph question. Like, for example, Here we have 1. Yes, we can sort. We can first see ones, right? They will go into different sets and 3 and 4. Then we will see 2 dominoes which have the value 2. And we will put the smaller number at the front always. Yeah, cool. Okay, shit. But yes, we are here making a gamble. We are supposing that these numbers are only appearing twice. Like here, 3 is only appearing twice, 4 is also 1 and 2 are also appearing twice, even though this is not said explicitly. But if they are appearing more than 2 times anywhere, then the answer is obviously not true. Okay, so if y greater than x, then swap x and y. Cool. And then sort a dot begin and a dot end. Cool. We have sorted the thing now. Bool rest equals shit. Yes, they have to appear only twice. If they are appearing 3 times, then the answer is of course wrong, because I cannot divide 3 different numbers into 2 different sets when I do not want two same numbers in one set. So yeah, answer would be false in that case. For int I equals 0, I less than n I plus plus, and we will keep 2 sets, VA as in like visited A size n plus 1, let's say, and VB size n plus 1. Right. And if at any case, let's say auto x and y, these are the two numbers, equals a I, if at any case, if x equals y at any point, then rest equals false and break. Okay. And if they are not the same, if they are not the same, then we need to put, okay, and also n is even, so we do not do this. Plus equals 2, we are increasing I by 2, and also this all a x y, and let's say I j, we are already using I, so we cannot even use a b x y j k rolling, j k equals a I plus 1. Now if x equals y, then no, or j equals k, then also answer would be no. Now we suppose that j and k are equal to each other, and they will go into opposite sets. And yes, now which sets do we put each of these into? That would depend on y and k. That would depend on y and k. 1 to 1, yes, that is cool. Then we see 3. Then we see 3, and that is also cool. 4 and 5, they will go into different sets. Then 4 and 5. So yeah, no for this. 4 and 5 are in the same set. shit, even this might not work. Every number we can only see it twice. We can only see every number twice. And what can we do? 22 minutes. We can only see each number twice. And if we are seeing any number more than 2 times, or yeah, more than 2 times, then answer would be false. And in this case, we are only seeing every number only twice. But it's still here also, in this case, when both the numbers in a pair are same, then also no. 1 and 2 are independent of the whole thing, but here these two are not independent. These two are not independent. A, y and k, ai plus 1, go to the next one. This did seem like a dynamic programming approach, but in dynamic programming, the state that we need is kind of messed up. We just need a lot of information. Yep, we just, yeah. Shit. Now I'm deciding between two approaches, and I think both of them are wrong. One is this one, which we have implemented here. This is, I think, constructive approach, and another is dynamic programming approach. And dynamic programming seems, I think, wrong. Not wrong, but unfeasible, because we can define a state using a single index, and we can ask if, when we are considering only the first I elements, I dominoes, is the state valid for them. That is something we can ask, but we just do not want this DPI to just store Boolean values, as in true or false. We also need a lot of other information to decide if we can add this I plus 1th new domino into our dynamic programming solutions from of the earlier state. And that is crazy. Maybe a recursive approach would be better, but no, we would, yeah, that would still, okay, shit, the number of subproblems would be a lot. The number of subproblems would be a lot. I think 2 power n something like that, and r, and shit, are the subproblems overlapping? Are the subproblems overlapping? When we are deciding for the ith plus 1 element where to add this, we need to have two sets, set A and set B. And I don't think we need a dynamic programming approach. And set A can have a lot of states, and set B can also be in a lot of different states. Yeah, I don't think this is going to work. Okay, dynamic programming, we can scrap it. Now this constructive algorithm approach. here we know each number must appear exactly twice. If it appears less than twice, like if there is some number which is appearing only one time, here every number is appearing two times. But if some number is appearing two times, it means there is some number that is appearing three times. And if that is the case, then answer is false. And also, numbers cannot appear in pair like this, where the domino has both the numbers equal to each other. That is also false. All right. And other than that, this graph, this just seems like there is some graph approach in this. Should bipartite graph? Should this is a bipartite graph actually? We start from 1, we go to 2, and these two are okay. Shit, I think this is a graph. We can convert this into a graph problem, and a graph problem would be easier to solve. We have 10 minutes. That would be nice. Okay, let's write these numbers. And wait a minute, just a minute. I will be right back. There is someone on the door. Where? Shit. Yes, I am back. That is nice. All right. I think we can use a constructive algorithm approach. Wait, no, not constructive. We can convert this into a graph problem. When we see a 1, okay, we will have two pairs of 1, and we want these into to be in different sets. I think there must be some way we can treat this as a bipartite graph and connect all of these like this. Hmm. And that is nice. And then, so these are the like connections we have to make, and everything is connected like this since these are in pairs. Okay. And are these valid? This shit. This is a valid graph. If we were to write this differently, like um, 1, 1, 2, 2, and these are connected as 1 is connected to 2 is connected to 1, and these ones are connected to each other. Okay. And then here the same thing. Okay. And then here, if we were to write this a bit differently, let's say we have 5, then on the other side, what do we have? We have 6, then here we have 5, then 7, but below 5 we do not have 5 connected. We only have 5 connected to 7. 7 is connected to other 7. That's right, 8 here, and here 7, and then this 8 is connected to the other 8, and okay, this 8 is connected to the other 8, and 7 is connected to the 7. And below 8, what do we have? 7, that is gone. 4, 8, 6. All right. And if we were to join these 5, 5, 8, shit, this is no connection. and these are connected. This is not a connection. Shit. They're not coming back. Okay. 5, 5, 6, 5, 7, 5, 6, 5, 7. And then below we have 7, 8, 7, 8, 6. That is what we have. And 5 connected to 5, 8 connected to 8, 7 connected to 7, 6 connected to 6. And I'm just trying to make this more visually make sense. These are connected to each other, and this is forming a perfect cycle. If things form a perfect cycle, is the answer correct? Here also we have a perfect cycle. Here also, here again we have a perfect cycle. So this is like coloring these. Yeah, and this is a bipartite graph. This is a bipartite graph. Bipartite graph. This is a bipartite graph. I think yes, we can, and we can convert this into a graph problem and see if we can make a bipartite graph or not, and that should be enough. Taking n, and we need a adjacency list, which we can just store as a pair, j n, pair of integers like this, telling us that the ith number or ith node, let's just use graph terminology, ith node is connected to these two other nodes. All right. Yep. Two other nodes. No. Yes. Node. Shit, why are we using one number multiple number of times? Okay, let's join these and write a single 5, write a single 6, and a single 7. 5 is connected to 6, we see that, and 7 is connected to 7, and this, and 1 is connected to 2. Yes. Yes, so we have merged this and made this a single node. We have also merged this and made this a single node. We have merged this and we have to write 8. 8 is also a node. 5, 6, 7, 8, and 5. Fifth node is connected to 6 and 7. 6 and 7. Sixth node connected to 5 and to 8. 5 and 8. And seventh node connected to 5 and 8. That is cool. And answer does not exist for this one. Okay. So we have this, and we can say that 1 is connected to 2 and 2 is connected to 1. That is the only information. So yes, this is a bipartite graph. Then 3, everything else, 3, 4, 5, 6, 7, 8. They are like a different, like they are forming one thing. We see that 3 is connected to 4 and 5. So 3 is connected to 4 and 5, and then okay, these two are done. And 4 is connected to 5, and this is not a bipartite graph anymore. Should this representation is actually working? If we are treating these numbers as bipartite graphs, then this representation is actually working. And in one of the examples, we have 1, 1 and 2, 2. This is a self loop. So no bipartite graph. Shit, that is cool. 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 Okay. And yes, I equals 0, I less than n, I plus plus, L, R, seen L and R, and we will say ADJ, L. Let's use a vector of integers here dot push back R and ADJ, R dot push back L, and then we will have a Boolean vector visited size n plus 1. Everything is initially like false, and then for int I equals 0, I less than n, I plus plus. And if not visited from 1, if not visited I, then check. We will write a function which will return a Boolean value and is called is by, as in like is bipartite. And this will take in a vector of integers reference ADJ, and yeah, it will tell us what the thing is, and bool response initially equals true, and if is by I and ADJ, then let cool. No, I don't think we need a visited. I don't think we need a visited vector. We do, so that we do not go to the parent for the current one, so that we do not go to the parent for of the current node on which we have called is by partite, or like, yes, that is kind of a DFS approach. I think vector bool group n plus 1. Which group does the I node belong to? And we will also have a queue. We will implement BFS here and not this Q literally just says Q. And if not visited I, if we haven't visited I, then put visited I equals true, and group, yeah, group number 0 and Q dot push I. And now while not Q dot empty, while Q is not empty, we'll take the first, the top element X, let's say, and Q dot front and Q dot pop, and pop the thing, and yes, we have this current number, and this will be connected to two other nodes, hopefully. And let's see, for int y that edg x is connected to. that EDJ X is connected to. Now, if not visited Y, then put visited Y equals true, and group of Y is going to be opposite the group of feel like somehow we have totally messed this up. Maybe the equivalence that we are using, the graph equivalence that we are using in this question, is it correct? Let's make this one completely. Yes, we went through this. Then 6 and 7 are connected to each other, and 8 and 6 are connected to each other, and then 7 and 8 are connected to each other. Yep. No bipartiteness. Shit. How do we prove this that they are correct? Let's write this first, and then not of group X, like opposite of group X. And here we have a strange thing in the actual group. If two things have a direct link connection to each other, like here 5 and 6, 6 and 8, 7 and 8, 5 and 7, then they are in the same group. 5 and 6 are in a group, like these dominoes 5 and 6 are in a group, and 5 and 7 are in a group. Okay, after we do this question, we will get into more theoretical why this might be working. Yo, no, Harit, Haritwik Kapoor. Yo, let's go. Shit, your name is kind of crazy. Lakshit Borana. Borana, that is a new surname. Okay, with this, cool. If the current node has not been visited, we put it as visited, and we say this node does not belong to the node that its parent belongs to. But if the current node has been visited, then if if this belongs to the same group as the parent, then shit, then group of X equals group of Y. If that is true, then this equals false. And also break. And here also we will see after this, if not this, if not possible, then break. And I think we are happy now. See out. Depending on this, yes or no. We are putting things, shit, we are not putting things on the queue. Q dot push Y. Shit, that is working. That is working. That is working. That is working. Okay, we are genius. Okay, that is working. First try. Let's see. Submit this and see if it works. 46 minutes. That is above time. If this is correct. Or this might not be correct. This might not be correct. Shit. Okay. Yes. And I think there is a mistake in this. mathematical isomorphism that we are using. We have converted this problem into a graph problem, and we are just finding out if there are, like, do you know about bipartite coloring? I think I know. What is it? I think his approach is wrong. Yes, I also think the same thing. Uh, here, but I think the part where I think the mistake might be in the fact that we are treating this as a graph problem. But in graph sense, I think this is correct. If the current node has not been visited, we also have to set, wait, its group is going to be 0 by default, so that is true. And we have two colors, color 0 and color 1, which we have in this vector. And yes, if we see that the current node has not been visited, then we put that current node as visited and we put it in onto the queue. And while the queue is not empty, we get the thing at the top of the queue and we go through its children or things that it is connected to directly. And we see if it hasn't been visited, then we color it into the opposite color of X and we put this Y new child as visited and we push it onto the queue. Otherwise, if it has been visited before, we check if its color is the same as the parent's color, then shit. We put resolution equals false and like response equals false and break. And when we are outside, when we are like in the other side of the queue, if not res, then break, and depending on res, we give true and false. I think the way that we are finding graph is good, respectful. Wait, what is this? Respectful? Shit. Res is respectful, yeah, yes. I think you should represent dominoes as nodes and not colors or numbers. Dominoes as nodes. If we do represent dominoes as nodes, let's see what happens. Let's say we are working with this. Here the answer is no. Let's use this one. Shit, that is already gone. Copy. Okay, we have this. And if we represent this as one node, this, how are they going to be connected? This one is going to be in other group, and these two will be in other groups, and shit, this is a bipartite graph. But we know that these two are in different groups because of this, one and one, that they are in the same group, that they are like, yeah, that they are same. And also 3 and 3 are same, that is why these two dominoes are in the opposite group, and 4 and 4 are same. And I think I just expanded on that idea a little bit here. If we have this, right, and here these two are in other groups, different groups, and we have these two are also like in their own separate groups, and these two are in different groups. This one is in this group and this one belongs to this group, and that is cool. And the connection is like this, that is nice. These two are connected because of the 7, these two are connected because of the 6, these two are connected because of the 5, and these two are connected because of the 8. Okay, and what I did is I connected these two with each other. Yes, I connected these two with each other, and we had 5, 7, 8 with a connection like this, and connected these two with each other, and 5 connected to 7, and 5 is also connected to 6, 6, and if we connect these to 6, 6 is on one side connected to 5, and 8, 8, shit, 8 on the other, and then, yeah, 8 is already connected. 8 connected to 6 and 7. To 7 and to 6. And this is a bipartite graph. Red, red, blue, blue. This is correct. I mean, this approach when we are connecting, and this, if we are treating these as nodes, and I call my function on this particular node, shit, yes, you are right. We can simulate to find out. No, we cannot. To find out which nodes this one is connected to, we see what is 5 connect, what are the other things that 5 is connected to, which is 6, and what are the other things that 7 is connected to, which is 8. And not just that, which node is this which has 5 and 6, and call our function on that, and which node is this which has 7 and 8, and call our function on that. And we can do that from a adjacency list. 7 would have the index of this node and the index of this node, and we will store all the nodes as a vector or of pairs of two integers, so the comma in the middle, this is a comma. So we will have two data structures, a data structure to store the nodes, like representing the pairs, these connections, dominoes, and another adjacency list vector where the ith entry would contain the indices of the nodes where of the nodes in which this ith number appears in. For example, if we say that this node is node number 1, this node is node number 2, this is 3 with the green, this is 1, 2, node number 3, node number 4, then entry number, let's say 5. Entry number 5 would have 1 and would also have 2, because node number 1 and 2 have 5. And if we have something like this, 1, 1, 2, 2 as the nodes, then entry number 1, entry number 1 would have, let's say this is node number 1 and this node number 2 would have 1, 1. Like these two things would be same, and it would mean this first node is appearing in the same domino twice, and that is messed up, self-looping. Yes. Bro, I think your college is affiliated with AKTU, then how you manage CGPA and attendance? I do not manage CGPA and attendance. I just do not go to college. Yes, my college is affiliated with AKTU. Yeah, my CGPA is 4.5 in the first and second semester, and 7.5 in the third and fourth semester. So yeah, I do not care about my CGPA. And not Linux never dies. That is crazy. Shit, we have given too much time to this. And I think the earlier approach was also right in some way, but we messed up somewhere. Vector of pairs, nodes or nodes, and this would have n plus 1 nodes, and vector, or internally this would have pairs. Yeah, and also vector of pairs. Yes, ADJ, adjacency list. I know. No, let's use something else for adjacency list. Vector of vectors. Vector of integers for auto reference x comma y in nodes. We take in x and we take in y, and what if we say we have to put this into the nodes? Okay. And I equals 0, I less than n, I plus plus, and auto reference x comma y equals nodes I. This can be just n and nothing more. C in n's and taking y, we have filled the ith node. Now we need to do adj x dot push back I and adj y dot push back I. That is the number x and y appear in node I. That is nice. And now we need visited vector bool or color size n plus 1. Initially everything is false. False depicts one color, and visited another Boolean vector visited size n plus 1. Initially everything is 0. Okay. And for now we need to iterate through nodes. Okay, we need to iterate through nodes for int I equals 0, I less than n, I plus plus. And we will also have a queue of integers. We will call it q. And if not visited I, if the ith node hasn't been visited, then q dot, this will be a pair, q of pairs. Q dot push I, no, q dot push ith node, and also visited I equals true, and now our internal loop, while not q dot empty, while q is not empty, we will do some things that CGPA matters. Go have a good sleep. Go have a good sleep. No, what do you mean? And targeting off campus, don't you think CGPA matters? I think I'm more focusing on developing skills, and I think I will be able to get a job if I'm like very, very good. But that is a big if. I have to get very, very good if I want a job off campus. And I think I will manage to get a job off campus even with not so much good CGPA, because I would have the skills to back it up. And I think that would be enough to get a job. Okay. And yes, while Q is not empty, we will take the top things, comma x and y equals Q dot front and Q dot pop pop it. And we have the top node from the queue, and we have to see the other things that this node is connected to, and the, this node is only going to be connected to two other nodes, and the indices of them are int I equals, wait, we cannot use I, and can we use a? Yes, we can use a. Int a is the node that, so there are two nodes, x, the number x, shit, yes, there is this current node and also shit, shit, yeah, yes, shit. There is this current node and also there is shit. So 5, 7 is connected to itself in the way that we have written this data structure. And that is crazy. We do not want that. We do not want a self loop. We do not want a self loop. So how do we know the index of the current node? We do know the index of the current node, which is I. Shit, yes, we do know the index of the current node, which is I. So that is good. And number x is appearing in two different nodes, and A and B. Okay. And if I, shit, software update, if I equals edj x 0, then A equals adj x 1. Else, I think this is a bad approach. Else A equals adj x 0. And if I is the node, is this current node which is connected to Y, we do the same. Yes, B equals adj x 1. And shit, I can feel that we are doing something wrong and there must be a better way. Yes, there has to be a better way other than this. Now, anyways, after this point, we do have A and B, which are other two nodes which are connected to this current node. And with that, we have to see if they have been visited or not. If not visited A, if A has not been visited, then put A, give A some color. A color equals not the color of this current node, which is I. Cool. We do not know the index of the current node. So I is only the initial node from here on which we initially called this, on which we initially started uh, going through BFS, but I is changing. All you have to know is how, shit, I think that is why the earlier approach which we were trying to apply, that was much better. I have solved 800 plus questions, but when it comes to story question, I get stuck. What do you mean story question? Help me out. Like I have solved in lead code, which is always a direct question. Oh, it's story question. Okay. Solving code force question needs more than just some algorithm understanding. It is more complex. Yes, you have to like. Okay, you can read. There is a article on code forces here by Mr. Umnik. How to read problem statements. This article might help you. And he says the result of reading the problem statement, the result of reading the problem statement, the statement is usually pure math model. If story, literally story, the word you used, if a story helps to build correct understanding, you can keep it, but still try to discard as many unnecessary details as possible. So when you are reading a problem statement, build a pure mental, pure mathematical model in your head and discard as many elements of the story as you can. Hello, Abby. Yes, he is roasting. I mean, Umnik can roast. And do you mean Umnik in Russian means a wise man, a man who knows a lot of things, a wise man. So he is kind of good. I think he can call himself wise man. He is LGM. Hi, can you help me out with combinatorics? What are the topics involved in COMB? Yes, CP handbook. We have binomial coefficients and things in combinatorics. Yep. If you mean combinatorics for competitive programming, you can go through this series, this chapter. You can just look up CP handbook and go to the combinatorics section and you can read this. That would be nice. Have you seen the little sheep yawn profile? Yes. Bro has been at it. Bro has been like at it for months, for years, and bro hasn't missed a day. That is crazy what he's done. Little sheep yawn right here. And I don't know why he just wrote a like very small introduction to his contest. Like look at this. 692. Then he is only going up. Bro does not know how to lose rating. And yeah, that is like crazy. Look at this. Look at this. Look at this. I think bro is aiming to get LGM in the next iteration, or maybe uh, to peak his to increase his rating by 400 or 500 points in the next contest. And that would be amazing. Look at this. In a row, 365 days in a row. And he has solved 39 questions at 3000 rating. His profile. Like shit, that is crazy. Look at this. Little CP on 90 contribution, 1000 friends. And he was online. That is crazy. Whatever he's done. And bro has not left a problem unsolved. Count zero. Every problem he is ever like submitted for, he's completed the problem. That is crazy. Shit. Unlike us. Unlike us. Okay, this is bad. I think, yeah, we can stop solving this current problem and we should move on to the next problem. And I will do this problem on my own after the stream, and that would be nice. Let's move on to the next problem. Yeah, shit. I messed up today also. Yes, shit. Okay, no, no, no. Let's continue. The first submission that I did for this problem, this should work, but this is not working. We take in these things and we push back, and this gave wrong answer on test number 2. I think we can, it is fine to look at the test case, which gave us the wrong answer now. Okay, I think it would be a bit hard to look at that test case. 1495 test case. Let's first recreate the solution which we submitted earlier. Take in this and vector adj n plus 1 vector and yes, create everything and in L and R for n I equals 0, I less than n, I plus plus, take in L and R and then adj L dot push back R and adj R dot push back L, because these two are connected to each other, and this must form a bipartite graph. This must form a bipartite graph. Now to check if this is a bipartite graph, we need a few things. Boolean, as in visited, size would be n plus 1, and color size would be n plus 1 because there are n plus 1 nodes. Yes, and then we will go n int I equals 1, I less than equal to n, I plus plus. If not visited I, then visited I equals true, and color of I is going to be false, like 0, And then we also need a queue of integers. We will call it Q. Boolean answer, NAS, answer or response would be fine. Let's say true initially. And while not Q dot, okay, we also have to put this onto the queue. Q dot push I, push I onto the queue, and while Q dot not empty, what we will do is we will go through all the things that are connected to this current node. And if no, for int x adj I, every x node that is connected to I, if not visited x, if x has not been visited, then visited x equals true, and color of x is opposite the color of I. Okay, yes, that is crazy. Set int y equals q dot front and q dot pop y, and we have to change every I with y. Okay, and color this current node, put it into visited, and put it onto the queue. And else, if this node has been visited before, then this cannot have the same color as the current node. That would be uh, if color of x equals color of y, then rest equals false and break. And we will break here, and if not, rest. Then break, and after here see out depending on rest, yes or no. And I expect this to work. Okay, cool. And this should work here also. This should work here. Yo, no, bro. He has not given any contest for the last. Yes, he has not given any contests. All the contests were like 3 years ago in October 2022, 2022, I think. And he has solved majorly 1624 rated problems, like 4K problems of this rating, 4,000 problems of this rating. He just gave 5-6 contests 3 years ago and became master and started making uh, own contests. Wait, shit, I thought this is his first contest. Little sheep yawn. I don't know what is going on in his mind. Okay, so he has not solved. So the majority of the problems that he has solved are in this rating and not here. Hmm. I, I guess he's just doing this to keep his mind sharp. Submissions. He's from China. 1500, 2000. That is nice. 1100? Why was he solving this? 1100 rated problem. Shit. And he uses Python and sometimes C++. Shit, why is he solving simple problems? And these, why don't these problems have a rating? And perfect result, 10 points. What even is this question? Shit. Some of these problems don't have like ratings. Yes, you are correct. He is solving easy problems. Look at this. I think these are after contest. Yeah, he was giving a virtual contest. Bro has given a lot of virtual contests. Little sheep yawn. Bro is into virtual things. All shit. Okay. 25th September ranks. Okay, we do. That is shit. Okay, bro is giving virtual contests. Why is he giving Division 4 virtual contests? Division 2, he can give Division 1 contests, so why not? Yeah, he has something in mind. Okay, and this does not work, and some random test case does not work, and the mistake is with our implementation. And should I implemented this code right now? So there is a mistake in our model. Yeah, shit. Let's go to the next question. Instead of spending time on a single question, we can look at this later. And let's move on to the next question. Fixed point. Okay, and with this question, we will do this. Like actually, we will get this right. Okay, cool. This is an interactive problem at 1600 rating. Initially, there is an array A to n where n is an odd integer. The jury has selected n minus 1 by 2 disjoint pairs. So one number is not paired, and then the elements in those pairs are swapped. Okay, for example, this. Okay, so every number would be changed except one number is not changed. And then the resulting array is this, and here 2 is the number that was not swapped. As a result of these swaps, exactly one element will not change position. You need to find this element. To do this, you can ask several queries in each query, you pick two integers L and R. In return, you will get the elements of the subarray A to R sorted in increasing order. Okay, find the elements which did not change position. You can take at most 15 queries, like, and the range. Okay, these will be sorted. That is okay. Okay. So if we do ask and to give us the whole array, that does not help because we will get the whole sorted array. And 15, I think we can use some sort of binary search here. The array A is fixed before the interaction and does not change after your queries. Recall that B is a subarray of A of A. If B can be obtained from A by deletion of several elements from the left or beginning input, we get 10, and N is odd 10 power 4. What is 2 power 15? 2 power 10 is 1024. 1024 into like 1000 into 32, 32,000. So not binary search. Wait, 32,000 is binary search. Yes, literally. Yes, 32,000 is under binary search. 10 power 4, that is 10,000. Yes, we can apply binary, some form of binary search on this. After reading the input line test case, you should begin interaction. It is guaranteed. Test case does not increase this. Okay, if we have something like this, how do we know? Time 1 second. L left and right. If we begin with left equals index 0 and right equals index 1, if we okay, we will decide on the specifics later. But before that, before that, hmm, before that, before, shit. We begin with this. Shit, okay. This is what we have, and if this has to be some sort of binary search because 15 queries, we only have 15 queries. And initially we say our answer exists in this range. And our central element would be this. How do we check that this number or okay, let's say we ask for this range or we ask for this range, let's say the middle element included. And if we do that, here we would get 2, 4, 5. And what can we tell about this? We know after getting this that in this range, ideally, we should have gotten 1, 2, 3, but we do not have 3 and 1. Therefore, 3 we can eliminate 3. Shit, we can eliminate 1, 3, and 4 and 5 as the correct answers. Shit, we have the answer 2. How can we eliminate all of these elements? We can eliminate because in this thing we expected to see all the numbers from L to M included, L to M, and yes, and we didn't got 3 and 4. Instead of, we should have gotten 1, 2, 3, but we got 2, 4, 6, 2, 4, 5. So 1 and 3 were not given, so they went to some place else. So obviously their places were swapped with some elements, and with which elements? 4 and 5. So 4 and 5 among the starting elements, 1, 2, 3, 4, 5, 1, no, 1 is not the answer, 3 is not the answer because we didn't get them, and we got 4 and 5 which should not be here. So 4 and 5 are also not the answer, 2 is the answer. Okay, or we can think about this in this sense that, yeah, that would be the only possible thing. And then, but, but, shit, what if our initial array or like our this internal array was like 2, 1, 3, 5, 4, and when we had asked for this range, we would have gotten 1, 2, 3. So 1, 2, 3 are candidates for the correct answer, and for this range, we would have gotten 3, 4, 5. So they are also candidate for the correct answer. Okay, shit. In that case, 3 is the correct answer because 1, 2, and 3 are candidates, and 3, 4, and 5 are candidates for the correct answer, and 3 is the only one that is in both the groups. So 3 is the answer. So, but we have changed our logic. We were not looking at the things which are the answer. We were looking at what things can we eliminate to find the answer. Hello, bro, how much do you study in one day? And how many days do you go college in one week? I do not go to college. Hello, thank you for this. And how much I study? I try to study as much as I can, but not enough. Like, I mean, reaching a rating of 2000 is a very difficult task. So we have to study. I have to study a lot. But yeah, I'm not studying as much as I should. That is unfortunate. And I'm changing that. 1, 2, 3. So there are like two different things. If we can eliminate some things, we will eliminate those things. Or initially, let's say we have a vector of all the numbers 1, 2, 3, 4, 5, right? And let's say we are applying our operation on this array and we got from this 4 to 5, and initially everything is true. Yes, this is all of these are possibly the answers, and we got 2, 4, 5 when we were expecting 1, 2, 3. So we can eliminate all of these numbers. We can eliminate this, and this. And if we can eliminate, we do eliminate, and we get to some answer, right? Cool, cool. And if we cannot eliminate, then, right, if we cannot eliminate, since we are taking this range and also we are taking this range, in this case, if you are taking this and this, yes, if you are taking the first three elements, you will get 2, 4, 5, and for the next, like, last three elements, you will get 1, 3, and 5. Here we should have gotten 1, 2, and 3. Here we should have gotten 3, 4, and 5, right? So 2 is a possible candidate. 5 is a possible candidate, and but we can eliminate. Okay, so first we will eliminate, right? Whatever we can eliminate, we will eliminate, and after eliminating, we will take a, like, union of the possible candidates, and we will store this in a simple one-dimensional vector and the number of operations. We cannot do more than 15 operations, and so in one case, are we eliminating half of the elements in one pass? Yeah, we will be eliminating. I think should be cool, but shit. Where do we go after this? Let's say we have some numbers which are possibly the answers, right? So initially our range would be the whole vector, right? From the start to the finish. But then we eliminated some numbers. How many numbers can we eliminate? How many numbers can we eliminate? Yes. Let's say this is the middle element and everything to the left is the left part and to the right is the right part. That makes sense. But with that, shit. Okay. With that, what do we have? With that, what do we have? Either some numbers changed place among themselves, or some number went to the other side and that number came here at this location. Those are the only two operations. And if something like this happened, then we eliminate possibilities from our answers. If something like this happened, what do we do then? I think we just yeah, we will first we will do this. We'll go here and we'll take this and this as Possible cases. Okay, and also we will have the earlier information which we can use. You can make at most 15 queries. Initially we made 2, then we made 2, 11, then 2, 7. 2 power 7 is not even close to how much we want to go. 777. Let's look at some of the things. Here we say what are the numbers in the range 1 to 4. These are the numbers in the range 1 to 4. Okay, answer is 2. Okay, we have 1 in the range 1 to 4. Wait, you are able to tell answer is 1? How? Okay, okay, makes sense. This makes sense. We had 3 numbers and we asked what is in the range 1 to 1. They said 1 and we said, okay, that is the answer. We want to eliminate as many numbers as we can in a single query. And how do we do this? So these questions are getting harder. I have to practice a lot more. I have to practice a lot more. I don't know why the earlier question was not working. For this, let's see. You can do this. We want to eliminate as many numbers as we can. And I think there must be like some mathematical genius thing here, which using which we can prove that this approach is kind of wrong, is kind of correct. At least we can make the point that this is going to use binary search because of this. The number of queries is 15 and total number of numbers is 10 power 4 and 2 power 15 is 32,000, around 32,000. So whatever the algorithm is, it is cutting the search space in half every time. Yeah. Course. Okay. When we are shit, okay, that is kind of stupid. Shit, okay. Here, when we have this vector, right, and we ask what are the numbers in this, let's say this is the middle point, what are the numbers in this range? And we know there are only 1 to n numbers. And when we have all the numbers in this range, we know what numbers are going to be in this other range. We do not want have to explicitly ask, tell me the numbers in this range. Like we do know that already because whatever numbers which were not here in this range are going to be here in this other range. Yes. So when we do ask for a certain range, we will be able to eliminate some numbers or maybe none at all. What if our initial vector is like 2, 1, 3, 5, 4? And what should be the range that we ask for? It would be better to take odd number of things. If we do take odd number of things, then, and if we still get 1, 2, 3, that means 1 and 3 are here, like 1 and 2 must have changed their place, and 3 was also here, but 3 cannot change places with other numbers. There are not just enough numbers, so 3 must be the answer. Yes, if we are unable to remove some number, then that is the number at the point is the answer. But then if we are able to eliminate some numbers, let's say, let's use a bigger example, 9, no, 11, with 11 numbers, and initially, not initially, but let's say answer is 5. 5 is at its place where it is supposed to be. And here we have 2, 6, 7. Okay, this is not even possible, I think. Wait, yes, this is not possible. We exchange 1 with 7 and 2 with 3, 2, 1, 2, 3, 4, 4, 4 with 6, 6, 4, and 7 with 1, 1, 8, 8 with 9, let's say, 9 and 8, and then 11 and 10. 11 and 10 changed their place. Okay, if we are able to eliminate some numbers, like in this case, when we ask what are the numbers in this range, 11 by 2, that is 10. 10 by 2, 11 by 2 is 5. 5, 5 is odd. So let's take all the numbers in that range, right? Here we are able to eliminate 7 and 6. And subsequently, we can also eliminate 1 and 4 as the answers. And the numbers that we were unable to eliminate, one of them is going to be the answer from here or from here. And not just that, actually, since this thing is being divided into two things and the total number is odd, n is odd, I think we can use that to our advantage. So one of them is going to be odd and the other one is going to be even. I think this is the answer. I think with just asking for the first 5 elements, we should be able to tell what the answer is. Just feel like that is true. Because let's say we are asking for a range with odd number of elements, and we can write a odd number as 2 plus 2 plus 2 plus 2 plus 1. And when we are eliminating numbers, we can, okay, let me think. When we are eliminating numbers, we are going to eliminate them in There are only two types of operations. Numbers go in different groups or they stay in their same groups, and there are only like so many pairs you can make. Once we have eliminated some numbers, the possible candidates that we are left with, they could be even or they could be odd. If they are even, then the answer is not there. If the number of elements which are left are odd, then the answer is one of them. And we were able to decide this in a single query. Why? Because if the answer is even, if the number of elements which were not eliminated, if that is even, there is a way to keep them in that list by pairing all of them up with each other. So none of them is the answer. But if they are odd and if still there is like all of them are contenders for the answer, then the answer is going to be in that range. And I think we have cracked Da Vinci Code. Okay, we can start with L equals 1 and R equals N, and let's go. Let's go. Okay, let's go. And how do we interact? How do we interact with the interactor? Yeah, we do this. We can like we can stop this and remove this. And that is fine. That is fine. We can have this. We don't even have to remove this. Yeah, we can we have this still if the two buffers are not syncing with the stream buffers are not syncing with the standard buffers of input output. I think this is fine. Yeah. Okay. Get n, get n, and vector n. Nope. And L equals 1 and R equals n. And where is our answer going to be? Possible, all the numbers that are possibly the answer, and this is going to be Boolean, and everything initially is true. All of them are possible. I think we don't even need this. No, we don't need this. What are the invariants? The invariance is that the answer is in range L to R, where L and R are both inclusive. So Y R is greater than or equal to L. Greater than L, actually, just greater, because if L and R are equal to some number, then they are pointing to some exact number, and that is our answer. That is our answer. That is our answer. Okay, now in m equals L plus R minus L divided by 2. And now we send our query. How do we send our query? We send L and R, C out, question mark L and M, question mark space L, or yeah, let's use printf. Scanf digit address in, and here after this printf. Wait, and what is the flush operation for printf? std, no, that is Python. In C++, C out, f flush standard out, f flush standard out. Part-100, let's go. Yes, let's go. What do we have? Question mark space integer space integer plus a digit integer anything, and L and M are the specified integers, and F flush standard out. And after that, we will take in the input. And how are we going to take in the input? We will create a vector. I think we don't have to create a vector. We can have a vector from earlier whose size is n, and yeah, we can just overwrite the elements in A. So for int I equals 0, I less than n, I plus plus, we will take in everything. We'll take in everything. Yes, how do we do that? We do that scan f, take in a digit, and give the address of A I, and the limits have to change. This goes, how many elements are we going to get? From L to M inclusive M minus L plus 1. Right. Cool. And okay, so we have the element. Now we need to see how many of these elements are not supposed to be here. Since this is already in a sorted order, yeah, we will see how many are eliminated. So in total, CNT, we have M minus L plus 1 number of elements. We can write here beforehand. CNT, we have go, that is how many elements we are going to get. And now we are going to eliminate some elements, which, and for which we will decrease the count. And yes, and we will see how many are still possible candidates. Yes. We expect to see S as the smallest number in this. We expect to see S as the smallest number in this. S equals L and AI is the smallest number that we got, and ideally L and I should be same, ideally. Now if AI equals S, that is, we have at this position what we expected, then the next number that we expect is S plus plus, and yes, I will just increment automatically. Else, if AI is smaller than S, that is the number that we got is smaller than the number that we expected. So we can eliminate this current number. Yes, we can eliminate. We can increase our count by 1, and the next number that we expect is also S, because AI plus 1 is going to be bigger than AI, and AI is smaller than S, so maybe the next number is S. Okay, else there is only one case. Now AI is greater than S, so we will not see S ever. So CNT minus minus. And yes, not just S, we will not see a bunch of numbers. And yes, we will not see a bunch of numbers actually. And the number of numbers that we are not going to see is CNT equals a maximum of 0, or the numbers that we are not going to CNT minus AI minus S, and there has to be a bracket here. And I hope we are doing the right thing. I hope we are doing the right thing. If we are not, that would be crazy. Okay, CNT is the current count of numbers which we suspect are like possible answers, and we got AI. AI is greater than S. S is the number that we were expecting to see, but we got AI. AI is a number that is bigger than S. And shit, we are changing CNT and I is going to the CNT, so that is kind of crazy. In REM equals 0, and instead of this, REM plus equals plus plus. And we will not change CNT, REM plus. So how many numbers are we eliminating here? We are eliminating rem as in like remove. We are removing all of these numbers. Right, in this case, wait, we are not actually removing anything in this case, right? Because we expected to see S, but we didn't see S. We are not actually removing anything. We might see S at the next place, to be honest. But yes, okay, rem is the count of the numbers which we are removing from the list that we have gotten. Yes, rem is the number of numbers that we are removing from the current list that we have gotten. We here are removing AI, and so this should also increase by 1, just 1. Plus. And what is our next expected value? S equals AI plus 1. What should that value be in this? I think no. We don't need a S, or we don't need, literally, we don't need anything. If L plus I. L plus I is the current expected value. If they are equal, then cool, cool. We don't even have to do anything. If L plus I, the current expected value, equal is not equal to the current value, then rem plus plus. Yeah, that's it. That Yes, right. That is much better than the other thing. Now, or CNT minus minus. Increase the count. Now, if CNT is odd, then the answer might be one of these numbers, which were not eliminated. Yes, it is one of these numbers which were not eliminated. And which number could it be? Cool, yes, makes sense. Which number could this be? That is a nice question. Odd, okay. And also if even, then none of these numbers is the correct answer, and we can move the left limit L equals m plus 1. But if one of these is the correct answer, then we have to do something. And shit, I am like taking more time than I should be. If one of these is the correct answer, then how do we eliminate? We will have to see all the numbers that we have eliminated, and yes. Shit, the answer is here. So we can remove the move the right limit. Right equals m. Shit, yes, that makes a lot of sense. That actually does make a lot of sense. And when we do know the answer, shit, why was I even thinking? Yes, this does make sense. Move the right limit. Move the right limit. Yes, of course. Yes, that is what we do. Okay, and after this, we do know the answer, and we printf this new line, comma, answer is R or L, anything. Standard out. Okay, we have two test cases. How many numbers are there in the first test case? 5. Okay, what are the numbers in range 1 to 3? Is the thing that the program is asking. In, let's say, this is a thing that we are working with. So in the range 1 to 3, we have 2, 4, and 5. 2, 4, and 5. Okay, what are the numbers in the range 1 to 2? 1 to 2, we have 2. Wait, we have 2 and 4. What is in the range 1 to? Shit, in the range 1 to 2. Shit. I messed up. Uh, shit. We had 4 in the range 1 to 2. Okay, okay. There is still hope. 5 numbers in total. In range 1, 3, 4, we have 2, 4, 5. Then in the range 1 to 2, we have 2 and 4. Then in the range 1 to 2, we have 4. 2 is the answer. Okay, for the next case, we have 3 numbers. We have, let's make our own case. This one. Let's make 2, 1, 3, 5, 4. In the range 1 to 3, we have numbers 1, 2, 3. Answer is 1. Bro just knows the answer. Shit, okay, I messed up. There are 2 test cases, 5 numbers, and in the range 1 to 3, we have 1, 2, 3, 3. Cool. In the range 1 to 2, we have 1 and 2. Answer is 3. Okay, okay, this is working. This does seem to be working, and we can submit this and let's see. Yo, what's up? Long time no see. Yes, coding on C language, C++. Yes, C++ with the interactive problem, and it is much easier to use printf, scanf in an interactive problem than standard output or input, or like input output streams. Sh- Thank you, but you are very ungrateful. No, I'm not doing amazing. Look at this. Okay. Answer is wrong on test case 2. I think the theory is correct. Okay, cool. Yes. How is everything going? There. Everything amazing. Everything is amazing. This doesn't work. This doesn't work. This doesn't work. This doesn't work. Scanf. I think this should work. This is not working though. Can we see the test case? Exit code is test case 5. How do you know this? Test 2, test case 1, 2, 3, 4, 5. Here, or something like this. 1 is the correct answer. Okay, here, or something like this. 1 is the correct answer. And let's go with it. Everything is awesome. Miami trip was cool. In California, I got 100 days badge few days ago in lead code. That is pretty cool. Nice achievement. We have 1 test case, 5 numbers. What are the numbers in the range 1 to 5? And we can eliminate 4 and 5. We will get 1, 1, 4, 5. That is wrong. Like, that is a bold lie. Why are we going 4, 4? Why did the left thing move? CNT. M is initially 3 minus 1 plus 1, 3. Take in everything. Okay, cool. S equals, why do we need S? What is S? And what do we expect as the first value? First value, one test case, 5 numbers. What are the numbers? 1, 4, 5. 2 is not right. 2 is not right. Because I do see the bug. Do you see the bug? The bug is like plain as day. How many 1600 rated questions left? Quite a bit. Print hello world. Shit. I can print hello world in Rust. I'll visit Finland for my dad's office tour after a month. This year is going to So well, full of trips. Yes, in Japan, California, Miami, and now Finland, Helsinki. That would be cool. How much you go college in a week? I do not go to college. I haven't gone to college in like months at this point. And yes, that's shit. The bug is right in our face. Look at this. Here I should go up to CNT, but CNT is being changed. Limit. Now CNT is not changing. Well, CNT is changing, but the limit here is not changing. And this should be cool. And yes, after this question, when I get this right, I will write hello world in Rust as you ordered. Cracklog JEE. Yes. Let's see. One test case, five numbers. What are the numbers in this range? One, four, and five. Okay. What are the numbers in this range? There would be one and four. What are the numbers in this range? One. Cool. 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 That does work. That does work. The mistake was this. We would have been able to figure this out without looking at the test case. It was an implementation mistake. Shit. Two test cases, five numbers. What are the numbers in the range? One, two, three. Now, this is our vector. In the range 1, 2, 3, we have 2, 4, 5, 2, 4, 5. And in why? Why are we going in the like opposite direction? We have two test cases, 5. And in the range 1, 2, 3, we have 2, 4, 5. CNT was 0. Shit. CNT was 0. Yes, CNT should be actually 0 because this comparison is not right. Yeah, int s equals uh, L and if s equals AI, if s equals AI, then s plus plus and yes, yo, and else if s smaller than AI, that is something. That is something. Okay. Current number is of course not going to be the answer. CNT minus minus. First of all, and if AI greater than R, then CNT equals 0. If we have already gone over the budget, then CNT is 0. And break, get out of this for loop. We don't need a else statement because if we go in the if, we will break. So in here, if okay, if AI is one of the numbers that we can expect to find, then we already did CNT minus minus one more number out of the range and S plus C. No, we did find one of the numbers, so no. Yeah, we do not do this. S equals CNT, no, set AI plus 1. because we have seen AI, the next number that we expect in this range is going to be AI plus 1, or minimum of AI plus 1 comma R. Yes, we cannot expect to see a number greater than R. Should not CNT equals 0. We have already removed some of the elements. Now we need to remove uh, all of the remaining elements. Remaining elements are lim minus I, because the current element is not a valid number that we expected, and there are in total lim number of elements which we do not expect. So this, and not just this, yeah, this. Yeah, cool, cool. I think that is right. Hello, schools are boring. Yes, they are. YouTube blogs, my comment. Maybe. Shit, what were you trying to do? Okay, that was a very specific information. Uh, Tier 3 college. I can guide you with uh, I can guide you with mm, how you can improve as a programmer. That is something I can do. You can join the Discord and ask people there. They know better than me about placements and things. I just come here and I learn things. And you have a new cat. That is shit. But now the cat is out of the box. Everyone knows you have a cat. Shit. That is pretty cool. Or if AI, the current number is greater, then did we expect to see this current number? If we didn't expect to see this current number, then remove the current number and all of the remaining numbers as possible viable options and then break. Otherwise, if we did expect, then put s equals minimum right limit or AI plus 1. Okay, cool. Only one condition left. When s is greater than AI and CNT. In that case, CNT minus minus increase count by 1, because this current number AI is not a viable option, and yeah, we might expect, we might see S later on. Ooh, and I think we should be good now. 2, 4, 5. Nope, we are still not good. 3. This should not be 3. This should be 1. This should not be 3. This should be 1. Why was this 3? We got in our vector the numbers 2, 4, and 5, and we started with 1. So S was smaller than AI. Mm, yes, S was smaller, S was 1, and AI was 2. The first number, AI was 2. And then we checked, is AI greater than R? Or it should have been greater than M. R is not the limit. M is the limit. There are two test cases, 5 numbers, 4, 2, 4, 5. 2 is wrong. So S was smaller than 2. Then we checked, is AI 2 greater than 3? No. Then CNT No, this was not true. So we went here and how many numbers did we not see in this range? Okay, after we come out, okay, we will take S as our measure of things which we are not seeing. Okay, okay. So here we are going to increase our S by some amount. Here we are going to increase our S by some amount, and that is going to be, we do have AI, and AI is a viable choice, and everything from S to AI is not an answer. So pnt minus equals AI minus S. Yes, AI minus S, and then what do we expect next? Next, X equals minimum of M, comma, AI plus 1. Okay, CM. Compile. We have two test cases, 5, 2, 4, 5. Shit, I messed up. Okay. Let me go to the washroom. I will be right back in a minute. So, gotta go. Recently, I am going to do 150 push-ups in a single go. It would be cool. It would be actually pretty cool to do 150 push-ups in a single go. That is cool. Yes, I am back, and we are very close to getting this right. I think at least. Yep, the stream is going up. Okay. And yes, it's compile. We have one test case, one, and the numbers that we have are 2, 4, and 5. This is still wrong. Yes, when we get out of the loop, we also have to do some things. Yes, when we get out, CNT minus CNT minus equals, we haven't seen S. If S smaller than or equal to M, then CNT minus equals M minus S plus 1. One test case 5, 2, 4, 5. Finally, okay, that is what we expect. And in the first two numbers, 2 and 4, are the first two numbers. Answer is 3. Wow. No, that is not the answer. How are we changing stuff? when we ask for numbers from range 1 to 2, we got 2 and 4. S was expecting 1, right? S was equal to 1. And we saw that this condition is false, but this condition was right. AI, which is 2 was greater than S. What do we do then? Then we say AI, we are checking if AI is greater than M, which it is not. M is equal to 2. So yeah, that is good. And then we do CNT, which is 2, 2 minus AI minus S. Mm, yes, because we haven't seen S and all the numbers till AI, but we have seen AI. So that is nice. And then S becomes equal to minimum of M. M is 2 and AI plus 1 is also, AI plus 1 is 3. Yeah, so yeah. Oh, AI plus 1. That seems to be the stuff of life. We have two test cases, 5 numbers, 2, 4, 5 are the first numbers. That is good till now. 2 and 4, what are the 2 is the answer. That is amazing. And in the next range, let's say we have this, where 1 is the answer. And in the first range, we have 1, 4, 5. Yes. Shit. Not this, but also a- R minus S plus 1 and minimum of the two. We have this one test case, 5 numbers, 1, 4, 5, 0. Shit, it should not be 0. This should not be 0. This should be 1. Here we are seeing 0. This should be 1 because at least 1 is a possible candidate for like the answer. Here minimum. Initially 1 is equal to 1. So we go past it and S becomes equal to 2. And AI is equal to 4. AI is 4 and S becomes equal to 2. So 4 minus 2 is 2 and CNT equals 3. That is something. And CNT becomes equal to 3. And here 4 minus 2 is 2 and 3. AI is 4. We do not expect to see 4. So we go here and we do limit minus I. I is 1. We subtract 2 numbers. So we have to change this. And shit, we have to change this. M minus S plus 1. One test case, 5 numbers. 1, 4, 5. Okay. M is 3. S is 2. -1, 2. So CNT should be 1. CNT should be 1. What is CNT? Actually, see out. Maybe this. Yes, shit. S, before going forward, S should be equal to M plus 1. Okay, okay. This might be it. This might actually be it. We have two test cases, 5 numbers. Initially, we have 1, 4, 5, and then okay, that is best. That is also wrong. That is also wrong. That is also wrong. That is also wrong. S equals M plus 1. Mhm. What are the values of C and T internally at the end of each loop? C and T initially is equal to 3. Then we take in all the three numbers and yeah, let's output printf CNT a number and print yes CNT and S is also a number and let's also print I. No, we don't need to print I. That is fine. Let's print AI. CNT S and AI. And let's also do this afterwards except AI. Yeah, except AI, everything. And also here compile run one test case 5 1 4 5. Okay, so first count was equal to 0 at the start of first loop and S was equal to 1. We were expecting to see 1. Then okay, so we went into this condition, S was equal to AI is true, so S increased by 1. We were expecting to see 2, but we got 4. 4 is greater than 2. Then we went into this condition and here M was equal to 3. 3 is smaller than AI. That means every number including S to the right. Wait, why was CNT equal to 2? M which is 3. 3 minus CNT which is 2 plus okay they shit. This should be minus. We are subtracting this number from CNT. We are not making CNT equal to this number. Shit, we have now one test case, 5 numbers, 1, 4, 5. Amazing, 1, 4, 1. Let's submit okay, with our hearts on our hands or something, or some poetry thing. Okay, shit. Okay, let's submit and hope that this works. Or maybe not. Wrong answer on test case 2. 1. Was it this? We have one test case with 5 numbers and the numbers are okay, it was working for this one. 1, 1, 4, 5, 1 and 2, 1 and 4, 1. This is crazy. What went wrong? Test case 72. We cannot check something at 72. That is too far ahead. Shit. Stream analytics. Shit, two people watching. That is nice. Fixed point guessing. How could this be messing up? Well, okay, let's go through this again. Answer is initially in the range 1 to n, and a vector is just like keeping answers, right? And when while our range contains more than one element, we will continue this loop, and we get the middle point m, and then we ask what are the numbers in the range L to M. We flush this, and we got M minus L plus 1 CNT number of numbers. Then we fill our vector A with that number, with those numbers. Lim is this initially how many numbers we do have, and S is the current number that we are expecting to see, right? If the current number that we are expecting to see is the number that we saw, then the next number that we are expecting to see is S plus 1. Now, if the current number that we are seeing is smaller than the number we should be seeing, then the number that we are seeing, then we check, is this number like even in this whole range? If this number is not in the range, then we say that we haven't got any of the numbers from the range M to S, where M and S are included. And the next number that we expect to see would be M plus 1, which is outside our range. And then we break. That is very nice. Except if this current number AI is in the range that we are expecting, then we will subtract this. That was kind of stupid shit. Like, this should not even be a concern here, because AI is in the range. AI is in the range. AI is one of the numbers that we are expecting to see, and we haven't seen any number from S to that range AI. And the next number that we expect to see is AI plus 1. Okay, we have two test cases, five numbers, 1, 4, 5, 1, 4, 1, 1. Okay. Next, we have five numbers, and they are this. It's 2, 4, 2, 4, 5. What are the numbers in this range? 4, 2. Answer is 3. Answer is not. Shit, it is my mistake. My mistake, because I entered 4, 2, but I should have entered 1, 2. Two test cases, five numbers. 2, 4, 5, 2, 4, 4, 2. Shit. Okay. 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 I don't know which time is the charm, but this might be it. Submit. Unexpected. This is not working. This is not working, and no one is even seeing. That is pretty nice. Test case 72 is crazy. Shit. We haven't even done a single question today. Let's look at the editorial. That would be the smarter thing to do. Fixed point guessing. D, this was D in division 2. Binary search. Yes, yes. Note that this equals 14. Yes, we did note that much, which is less than the number of queries. If we can answer, uh, if you can ask a question in the form of given a subarray, does it contain the fixed point? Then we can binary search on the array, the fixed point. Given a subarray A to R, let's count the number of AI such that AI is in that. I think we have to change this approach that we are doing. Yes, this is more complicated than this needs to be. Like remaining correct equal CNT. If AI is in the range, if AI greater than equal to L or AI and and AI smaller than equal to R, then this is one of the correct ones. So that is all we needed. And after this, if correct is like odd, if the number, and then answer is going to be in the range L to M. If not, then L equals M plus 1. M is also not the answer, right? M is also not the answer. Okay. With that, let's see, check again if this works or not. Do not say that the answer is wrong. We have one test case with num shit. Shit. I do see the bug. This R has to be M. Submit, 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 submit. This has to work. This has to. Okay, okay, okay. Look at this. That is nice. That is nice. That is nice. We got it. That is nice. That is nice. We got this. Cool. 1 hour and 25 minutes. And I don't think we will be able to do 4 questions. We have only done one question. We can do one more. We can do one more, but let's read the editorial for this one. Given a subarray L to R, let's count the number of AIs such that which are in the range. First, yes, we claim that if this count is odd, then the subarray contains the fixed point, otherwise it does not. Yes. First, let's show that each swapped pair either increases the count by 0 or by 2. Suppose that this are swapped. That is uh, ax equals y and ay equals x. If ax is in the range L to R, then y, since ax equals this, okay, y is also in the range, so ay is also in the range from L to R. Similarly, if ax is not in the range, then neither is ay. So this here increase the count by 0 or 2. Okay, wait. Suppose that x is swapped with y, right? That is, ax is some number and ay is some number. If ax is in the range L to R, then y is also in this range, since ax equals y, so ay is also in the range L to R. Similarly, if ax is not in the range, then neither is ay. Okay, that proof is kind of confusing, but okay, we do get the point. Contrary, the fixed point increase the count by 0 if it is not. Okay, sure. If they are increasing the count and ax is in the range, ay is in the range, then they increase the count by 0. And if they are swapped outside, ax is not increasing the count, ay is also not increasing the count, then 0. Okay, cool, makes sense. And yeah, cool. So we can move on to the next question. We got this right. Hopefully, we did get this right, and kind of don't even feel bad. I feel nice. We can do one. Okay, let's see how many more questions we can do. Cool. Okay, and let's go to the next question. Rank has increased, kind of 157. Cool. Now, this one is the next question. Let's get this one right. Okay. Maximum product strikes back. Okay, cool. Start the timer. You are given an array A consisting of n integers. For each integer I, 1 to n, the following inequality is true. Every number is between -2 to 2. You can remove any number, possibly 0, of the elements from the beginning of the array, any numbers from the end of the array. The following, you are allowed to delete the whole array. Also, you need to answer the question how many elements should be removed from the beginning of the array and how many elements should be removed from the end of the array, so that the resulting array will be an array whose product multiplication of the elements is maximal. Okay, if there is more than one way to get an array with the maximal product of the elements in it, you are allowed to output any of them. The product of the elements of an empty array, 0, of an empty array should be assumed to be 1. 5. Okay, we multiply everything with everything, and we just need to find the range, which we do not want even number of elements, even number of odd elements. That is something, right? So just remove this, even number of odd elements. So either we go with this or we go with this. Here we get 2, here we get also 2, here we get 1. So yeah, we remove this here. And yes, we do not want 0 to be in our range. And here we would rather remove this and go with this. And here we would remove this and go with this as a range, and answer would be 4. remove one element from the left and zero elements from the right. Here, remove one element from the right and zero elements from the left. What is the maximum product that ends here at this current element? Here, if this is going to be like the last element that remains in the vector, then what is going to be the maximum product? The maximum product by initially is so either we take this element and take whatever the maximum product of the last one is, add this element to that, or but also we have negative numbers, which is not very cool. We have negative numbers, which is not very cool. And this is sort of like maximum sum array, like where we use Cardane's algorithm. Shit. But the thing is, we do not just need to find the maximum sum. We need to find the maximum product. We need to find the range of that thing which is the maximum. We can do that. We can do that. We can do that by keeping some extra information with us. Right. -2. When we are at -2, we say we do not want this -2. Yes. Okay. Let's go with this and do some hypothesizing. We are, let's say, I, and we are asking ourselves, or we are at any random index I, and we are asking ourselves what uh, what would be the maximum product that we can get where this current element is the ending index. So that would either we just include this current element, right, or we include some elements from the left. And how many elements from the left? If we are going to include some element from the left, that would mean, so yes, the choice is the best choice, which is for this, is it also the best choice for this? If we are going to put this element here with this, so yes, this is going to give us the maximum possible answer we could get. No, that is not it. Shit. Because for this number, this 2, the best choice is to not include this 2, because including this 2 would make the product -4, and that is not good. Instead, this 2 would not include this other -2 and would have its maximum product as 2. Now, then this one, when it is here, we should, yeah, have this as the thing. Mm. But maybe we don't have to use the best from the left. We have to use the left. Okay. Yeah. Let's say we have a left index, right? Current thing currently. Yeah, something like the Cardane's algorithm. Cardane's algorithm. Yes. C current would be -4. Then either we use this with the current one, current best. Best would be -2, and when we add this, current best would be 2. Nope. Nah, this is reducing the number. Shit. The negative sign. Okay. So this is not dynamic programming, or maybe this might be dynamic programming, but with some other approach other than saying DPI has the best product where I is the last element, because that clearly is not going to work. That is not working. So we need some maybe other dynamic programming approach, but no, this does not seem like a dynamic programming question here. So 0 is like splitting our vector into multiple parts. This 0 is splitting our vector into multiple parts. And what we need, right? So the answer would be the best answer here or here, right? Yes. After excluding at every 0, we are like dividing the whole thing. And then, yes, then the best answer would be as many elements as we can choose, which we will have to find all the ranges which have even number of negative signs. Uh, yes, in each of those ranges which we splitted at 0 individually, left to right. Now there are going to be some negative numbers in this, and we need to see all the ranges in which we can take, which we get even number of negative numbers. So when we have two negative numbers, these are the possible ranges. Well, it would always be better to take the biggest range. Yeah, yeah, take the biggest range with even number of negative numbers. Yeah, shit. So this might have a negative number on the left, and yeah, yes, and this is going to have some amount of negative numbers. And if the in one passing, we will be able to determine how many negative numbers are in this. If the amount of negative numbers is even, then the best answer for this range is going to be the product of all the numbers. But if the amount of negative numbers is odd, then we need to exclude either this negative number or this negative number. When we exclude this negative number, then our product is this much. And when we exclude this negative number, then our product is this much. And we see whichever is the best one. Cool. Cool. Shit. This does not use dynamic programming at all. Like, no, this is fine. This is fine. vector int a type n, and yes, take in all the things. And we also need something to be able to determine what is going to be the product of this whole thing, and a function which will take ranges L and R. Yes, ranges L and R vector A and the prefix product, and it will return three things. It will return L and R, the range, and this product, the best product we can have in this range. And these values of L and R which are returned might be same or might not be the same. So, okay, so okay, we need to make a prefix, long prefix type n+1. Okay, and pref 0 is 1 because we are taking product. I equals 0, I less than n, I plus plus, taken ai. And after this, if ai, that is, if ai is not 0, then pref I plus 1 multiply by equals pref I into ai. Else, if ai is 0, then pref I equals 1, or maybe I plus 1. And we also need to keep track of all the zeros, ZR, and whenever we do see a 0, and also it would be nice if we could have, with the indices of zeros, the number of negative numbers that we have seen with the, let's call this segments. It, and this is going to have a pair. Okay, where first number is going to be the index of 0 and second number is going to be the count of negative numbers. And the first segment starts from, the index of 0 would be -1, and this is included, but the past one is not included. Okay, and the number of negative is 0. Okay, and also in neg equals 0. If the current number does exist, then neg. And also if ai is smaller than 0, then neg. Plus plus, if the current number is negative, then first of all prefix I plus 1 equals 1, and then seg dot push back. We have another segment which ends at I inclusive, and the number of negative numbers here is neg, and then put neg equals 0. And when we get out, that is also end of a segment. Yes, that is also end of a segment. That would, if the last number is not 0, yeah, if a n minus 1 is not 0, then seg dot push back I n minus 1 comma neg. Now we have our segments. Yo, 35 days till first stage of I. Oh, I am nervous as hell. That, I cannot even imagine. I get nervous during a normal code forces contest. IOI 35 days to the first stage. Do we have to like go to some place or it is online? I don't think it would be online. How many questions you solved daily now? I try to solve 10 questions. Try is not a good word, but yes, 10 questions is the target. In today's stream, we have solved only one question, right? I guess these questions are hard. I mean, of course, they are hard. These are 1600 rated questions, and these are hard. Look at this. It took 1 hour and 25 minutes for this question. And the other one I wasn't even able to do. So I guess I have to tone down, or maybe I have to increase my practice. Offline, and IOI will be E bro is going to Cairo. So that is amazing. Egypt, IOI. Okay. And that is pretty cool. You didn't give last contest. Yes, I didn't give last contest because I, I want to increase my rating. So I will practice and then give the contest. And I guess today I will give virtual contest for the last contest. Offline, of course, not on the stream. Yeah, and you do not have to give all the contests which are out there. First you train, then you give contest. And in the meantime, you give virtual contests. I think that is pretty nice. Okay, here we have the segments now. And L equals n minus 1 and or long best is 1. And now we have to write a function x comma y or I, yes, I com hmm I comma neg n seg for in I equals 1 I less than seg dot size I plus plus. And yes, we have to write a function, and that function will give us a couple of things, and let's write a tuple for that. How do you write a tuple? Uh, Using TP equals tuple of integers. We need best and yes, we need best and things. These people will have long int. Yeah, I think that is good enough. And we will get a tuple TP, let's call it C, from the function, and function will give best in best in what? The range is seg I minus 1 dot first plus 1 and seg I dot first. That is the range. And array, if you need a, do we need a explicitly? It has to be I minus 1 because I is 0. Here I is 0 and I is pointing to a non-zero number. Okay. Given the ranges, this range begins from this and this L and R. And do we need a? Will that function need a? No, vector. Why am I saying this? Prefix. Okay, let's write the function. This will return a TP and what even is the name of the function? Give best. That is what the function is called. And integer L and integer right and vector long reference pref. Okay. But one more thing we also need to know. Should we don't even need to know the number of negative numbers, because if the product in this range is negative, then the number of negative numbers is like odd. Shit, we don't even need this neg. So neg can be a normal integer. Seg dot pushback, seg dot pushback -1. Cool. And we don't need neg. Nothing to do with neg. Seg dot pushback I -1. What if the okay, starting number is 0? What if, yes, what if the starting number is 0? Then also our range would be like nothing. Okay, cool. TP triple C equals get best, and left is seg I -1 and right is seg I. And we will only call this function if seg I -1 is like smaller than seg I. And also given the prefix, which will be required by this function. Okay, now we have a lot of things. Okay, and long P equals product range R, every number R +1, R is included. Yes, R is wait. Here we have to do +1 because the last number is not included in this current range. If R +1 divided by pref L. Now, if negative, if P is smaller than 0, then we do something else, return L comma R comma P. Otherwise, here if P is negative, we will first move left and then we will move a bit right. Okay, PL and PR. So from the left, we have to see the first time when the prefix becomes negative. Shit. Oh, yes. Yes. And okay, one question, test.cpp. If we do include ptr.h int main cout, we have -4 divided by -2. What can we expect to see? G++ test.cpp. Okay. Uh, iOS 3 G++ data test dot slash out. 2 is pretty nice. Yo, good morning. How is everything going? Good morning. Things are kind of going terrible here, but I guess we have some time. We can do this in 40 minutes. We can do this one. And it's this is the question. This is kind of like the maximum sum survey. Everything is good. That is amazing, and that is also very subjective. I mean, yes, of course, you will give a subjective answer to a subjective question. Shit. Okay, let me focus. Not that you're distracting me. You PL, comma R. And yes, are you on the Discord? That would be nice. In the Discord server. Shit, of course. Shit, yes, of course you are. Of course you are. Shit. Yes, you sent me the bind. Yes, the brain is not working correctly. Yes, okay, shit. So, yeah, if I find anything cool, I will be sending you personally those things. That would be nice. Okay, so now what we have to do is find the first element in the left that is negative and the first element on the right that is negative, or we could instead just have the a vector given to us, and that would make things easy. S- yes, okay, and in I equals 0 or I equals L is included. I is smaller than equal smaller than R, we won't go to the rightmost element. Maybe the rightmost element is the negative number. Equals R I plus plus. Now, if AI smaller than 0, then fail. Now, here I is smaller than 0. Uh, I is a negative number. Now, if I is smaller than R, that is the first right number is not the number on the like total right. Then we exclude that number and take the product of all the numbers onto the right. Yes, and that would mean we take product of all the numbers onto the right, and that would be product of when we are excluding the left negative number, product would be prefix r plus 1 divided by prefix I plus 1, because we do not want to include I in the final answer. Else PL equals like 0. there is, or 1. There is nothing on the left. 1 might actually backfire, so 0 is much better. And now for the numbers on the right. For int I equals r, I greater than equal to L, I minus minus, if ai smaller than 0, then break, and if I greater than L, if there are like some numbers on the left, then PR when we are removing, and the first negative number from the right, we will get pref. We do not want the ith number, so just I divided by pref L. We do want the L number, else PR equals 0. And what do we return? Return, okay. Now, depending on which one is best, if PR greater than PL, if the product on the right is greater, L is the left limit and I minus 1 is the right limit, and the product is PR, or we don't need else, just return I plus 1, I is not included, till R is included, and PR, PL. Now here we have to deconstruct. Okay, there have been some errors, yes. Undeclared identifier get best, that is what we do here. Give best, that is right. How many have you solved on lead code? If you do, I do not like do lead code with full focus. Let me see. Lead code is not the primary thing. Last submission was 1 month ago, and yeah, 155 questions and just 58% acceptance rate. That is it for lead code. And yes, here, yes, after getting this segment, we have to see, we want to deconstruct how to unbind how to unpack a tuple. I think there is a newer syntax and we can use the same syntax. Damn, that is great. Thank you, Sharon. My name is Sharon with the emoji 17, or later we can just do this, the normal unbinding syntax. That is nice. Let's do that. So we don't even need this C. We can just do auto and LSB stop. Wait, LSB stop. Yes. Auto L comma R and shit. L and R are not the thing. CL and CR and PP as like the best product. Now, if PP greater than best that we have seen, then L equals 0, L equals minus 1, and R equals minus 1. Yeah, int L equals something, R equals something, does not matter what the thing actually is. Here we will update L to be CL and R to be CR. Current value of L and current value of R. Yo, I just started doing lead code since a month. Sometimes I'm not able to build the optimal solution by myself. You got any advice? Yes, just keep solving questions. Practice is literally the only thing which can help you. And if you need a proof of that, I can say you this right now is the like stream number 100. Somewhere it is written this is stream number 100, and if you go to stream number 1 in competitive programmer series, you can see I didn't know anything, and just practice and being consistent. By being consistent, you will get better, and that is the only advice. And yes, whenever you are solving a question, make sure that you do understand what you have done. Just solving the question is not the main thing, and if you do understand what you have done, that is the main thing. Now if now at the end, if answer equals 1, then see out, remove everything from the left, space 0 and 1. Else else see out L plus 1, see out see out L and space from the right. How many numbers do we need to remove? N minus R minus 1, N minus R minus 1, and hopefully answer is not a thing. Yes, answer is not a thing. The thing is best. Okay, I expected this to not do this. I expected this to work. Okay, I'll be right back. Thanks, man. I do practice, but it is just sometimes the question just flips me. Yes, like I understand what to do, but not how. Yes, with time and practice, those things will just become easier. And yes, that is the thing. Just practice, and these things will come more naturally. And yes, I'll go to the washroom right back. Yo, hello, I'm back. By the way, do you click so much in between after you write the code? What's that? Wait, what? In between after you write the code, click so much. What do you mean? That thing. This. This is like, I don't know. This is a habit. When I do this and enter W and press enter, this saves the current changes. So this is just like saving the current file in new vim. And yeah, that. Wait, you are able to see the new, hear the voice? Shit. Okay, shit. This should not be happening. I think now it is better. Shit. Now it should be better. Shit. Okay. Yeah, now it should be better. It is cool. Okay, that is nice. I mean, the keyboard is blue switch keyboard, and blue switch is not good. Red switches are better. Without the noise, it just feels too silent. Shit. Okay, I will find the best amount of noise that should come from the keyboard so that it is not too loud and my voice is also clear. I would like I would have to experiment a little bit and yeah, I will find the right setting for it. But I think without the noise cancellation, both you were okay. Ah, okay. Without the noise cancellation, the voice would be just a bit too much. Okay, here the actual answer. We say remove everything from the left. Actual answer here should be two, not this. This is bad. This is bad. Okay, what do we where are the segments? We only have one segment. Okay. Here also, yes, we only have one segment. One segment. What is your rating? Yo, a weak engineer lead code and code forces. What does this question say again? Okay, I will explain. And my rating currently is 1400 on code forces. I do not do lead code much. I don't know about that. What does the question say? Question says this is the question, and we have been given an array, and we have to find how many elements do we remove from the left and from the right so that whatever the remaining array is, it has the maximum sum, maximum product. And yes, that is what I'm trying to do. What I have done is I have split the array whenever I see a zero because we never want zero to be in our array. And also when we have removed all the elements from the array, answer is going to be like 1. When our array is empty, then we can suppose that the product of the sums is 0. When the length of the array is empty, then we can assume the product to be 1. And yeah, I think the approach is correct. Just implementation is a bit messed up. Okay. This is cool. This is exactly what we need. Yes, this is cool. And here 1, 2, -2, -4. -4 is negative. So here we will see that the product is sorry, the product is kind of 0. How is the product 0? How is the product of the array equal to 0? That does not make sense. Let's start with the prefix vector. Wait, shit. Yes. Yes, of course it is 0. No, it is not. let's see, this is this if AI prefix size is n plus 1, and if the first element is 1, cool, then we get the first element, and that first element is 1, which is true, as in like positive, which is non-zero. So we are updating this value. Okay, I see the bug. Do you see the bug? We are not multiplying AI plus 1 by this thing. We are making it equal to this thing. Shit. That was a stupid mistake. And everything else should be nice. Now, wrong answer, but yes, wrong answer. What are the products? Product, okay, in the first case, product is negative, which is true. This is our range, and the total product is negative. So, what we will do, we see here that the product is negative. So, we go in here and we see when we remove the all the like the leftmost negative number, then what would be the product then of the right numbers? And if we, yeah, okay. So here I starts with L, which initially is equal to 0. I will go up to L. And if at any point we see that this current I is a negative number, we exit. And then we are comparing I with R if there are some numbers left. How long does one question take? Okay. Now it is taking like increasingly longer because these questions are pretty tough at a rating of 1600. The last question, which we just like did before this, it took 1 hour and 25 minutes. Yeah, I think I should tone down the difficulty of these questions. That is one option, or maybe increase the practice. And I think I should increase the number of questions that I'm solving. Not on a stream, yeah, of course, of the stream also to build some speed. I equals 1, I less than equal to R, I plus plus. Yes, the first negative number we get, it will be at index 2. Yes, and 2 is smaller than 3. Yes, then the left product, let's change the naming scheme a little bit. Yeah, that is nice. Okay. Here we have PR in PR product of all the right numbers when we are not including the leftmost number would be R plus 1. Get the product of all the numbers in like up till the R number divided by I plus 1, which also includes the ith number. That is cool. So we get the product of all the R like numbers, which should be like 2. And in the else case, the R is 0, which is true. Then we find the first negative number starting from the right thing, moving back towards the left boundary, I minus minus, I greater than equal to L. And if I is greater than L, that is, if there are some numbers left on the left side, then the product is going to be all the numbers till the ith number, not including the ith number, divided by the products of all the numbers till the left number, not including the lth number. Lth number is not included in the division, therefore it will be included in the product. Otherwise, we'll use this. Okay. Now, if the products of the right numbers is greater than the products of the left number, which is not the case here. Uh, right, so that would the left limit would be this, and the right limit would be r. R would be included. But if the product of the left numbers is greater, then R left limit is this, and shit. Okay, I messed up. I messed up. I messed up. I is changing in both the cases. Shit. I is changing. Let's make it I L and IR. Shit. That was one mistake. V2 is solve all problems of 800 level, then move ahead. Shit. 800 level problems are, I think it would be wasting time solving 800 rated problems. I could instead be solving more difficult problems. And here you must know about this thing. Here I want to replace all the i's with I, L. So substitute I with I, L with the G command. Shit, except this one, and also this one. And here we want to do the same. But since we do not replace I, substitute I with IR globally, but we want to confirm all the changes. We just do not want to blindly change everything. Then we do the C flag here, use C. And now it is asking us, do we want to change this I?
Of course, this is wrong.
This, not that we don't want to change this I should not even be here. Yes, anyways, change this one. Yes, no, yes, no, yes, yes. Okay. If right is right, then IR, IL plus 1, and here IR minus 1. Okay. Okay, this is still not working. Time for me to study a little bit. Yes, you have to study. You must have heard about this book by Mr. Pope himself. Like he wrote the foreword to the book, Practical Way. This little line here says forward by Tim Pope, like literally the Pope. Pope is on web. ION do C++. So I'm just trying to understand the code. ION, what? I didn't. Yes, Pope. Pope wrote this book. Yeah, same. Practical Way. Why is there the Ubuntu logo here? And yes, LFS. Oh, thank you. ION. I do not. Yeah, I don't. Shit. CPP is nice. I think you can. Everyone should do CPP if they are computer programmers. Not because C++ is good, but because it requires you to be a good programmer. Like noob programmers cannot write C++ like in a very good way. And yeah, so you should learn C++ because it like filters out bad people, and it will make you stronger, like David Goggins mentality. Anyways, EL smaller than 0, then this. If this is smaller than R, EL, yes, 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 let's see. 2 and 2. So what is the problem with this? 2 and 2. That is the best thing we could hope for. PR and PL. So this is performing correctly. 2 and 2. And here, okay, so the mistake is here. Our function there is not causing anyone any trouble. Learn CVB to go to learn X environment, then write C gigachad mentality. Shit. And do this as a newbie. That is true, but I just feel Python is easy to understand. That is what the sole reason I use Python, because it is easy to understand. It is easy to understand, but you are not getting any resistance, I think, with that. And resistance makes you stronger. And yes, if you are a noob, like beginner, not a noob, if you are a beginner, go to learn X environments and learn C++ as your first language. Shit. And do not even use any C++ features later in your career. Nothing except C. What do you mean by resistance? By resistance, I mean how much difficulty are you facing doing something? The more difficulty you face, the better you get. But if you face too much resistance in performing something, then you might give up. Yeah. So there has to be like a perfect balance in smoothness and resistance. Because if you do not feel any resistance, if everything just seems very, very easy, you write A equals 10 and like, yeah, if everything is very easy, then you are not learning a lot. But if everything is very difficult, you cannot even write hello world, then maybe tone down the resistance and do something easier. So resistance has to be at the right place, right amount of resistance. We here best. Yes, we go printf CL a number and CR a number and PP, which is also a number, and then a new line. And these numbers are CL, CR, PP, and F plus CD out. PP is greater than answer, which initially is equal to 1. 1 and 2. Cool. 0 and 1. And shit. Do you see this thing? If you are still here, AY clips, do you see this thing? Why? o- Okay, for every test case, we are first printing the printf function and then we are doing cout, right? So we should expect to see for each test case this line and then this line, but that is not what we see. We see that first of all of these lines are printed and then these 4 lines are printed separately. So why is that? Any idea? And this is like very cool subtle thing, not subtle, yeah. This tell me how much you know. I mean, you already know quite a bit. Linux. Yeah, we'll do LFS at some point. LFS would be nice. Best equals 1, then okay. The mistake is we are not updating the best. And the reason for this behavior, okay, now we are acting as good adults. Shit. Remove one number from the left, 0, 1, 0, 4. 0, 4 and 2 0, both of them are correct there. Maybe because it is running in the if statement and would complete after is that it. No, wait, let me understand what you are saying. Maybe because it running in the if statement and would complete after it. Okay, so this thing is you're saying this is in the if statement, and but this is also in the if statement. But my point was that during when this is a function that we are calling, right? And from each function we are getting to this function called once, at least once, and also this to this function called at least once. So you would expect, let's call this line number one, line of type one, and call this line of type two. So whenever you call a function, you would expect to see for each function call first line of type 1, then line of type 2, then again for the next function call, line of type 1, the above one, and then this 2, something like this 1, then 2, 1, then 2, 1, then 2. But that is not what we see. What we see is we see 1, 1, that is 1, and then 2, 2, 2. So all the lines of type 1 are being printed first, and then the lines of type 2, even though they are not being called in this order. And the reason is here we are using printf and then we are using flush. So when we use printf, all of this string which is supposed to be printed onto the terminal is put inside a buffer in the memory. And when we do this statement flush, that buffer is emptied and everything, all the string that was in that buffer is put onto the screen. Right. So when we call this function, this line goes to the terminal screen immediately. But when we call this line, this is also put into a buffer, but we are not doing any flush. So this thing only gets printed onto the terminal when the program ends. But this line gets printed onto the terminal as soon as it is like called. So how can we like get this pattern 1 2 1 2, which is the expected pattern? We can get this if we do uh, cout plus. We should get this. Let's see. Yep. Now we get this. First, this line is printed, then this, and this, and this, and this. That was just one of the things that you will get to know if you start doing C++, because it is running, giving on 10th. I don't think so. I want to practice much more before giving any contests so that my rating goes above. And I want, yes, yes, that is same. And not this is not like very difficult thing to understand. If you just go and read about it, this makes sense. Even though when we got that like strange output beforehand, it felt like, wait, what? Why is this happening? And you might have given up. But if you go into the internals, you will be able to understand why this is happening. And if you do understand the internals, you will be able to experiment with them, and that is cool. And no, I want to increase my rating to 1500 in the next contest. So yeah, I need to practice a lot, and then I will be giving the next contest. That is the correct answer for all of them. 2-0 for shit. 2-0, 2-0 is actually the correct answer. Wait, yes, yes, 2-0 is the answer, not 0-4. 0-4, 0-4 does not even make sense. One test case with five numbers, these being the numbers. Two, two. Okay, shit. This should have been four instead of being. Yes. Do ping on Discord server when you will give in a contest. Okay, I will tell you when I'm giving the next contest. Yes. And if you understand what I was like trying to say, then that is pretty cool. Understanding these low level things like makes you shit 4 hours makes you feel pretty cool. Okay, so what was P here? And we might need this. One test case which has five numbers, which are these five numbers: 2, 0, minus 2, 2, minus 1. 2 is not, 2 is not right. We have one test case with five numbers: 2, 0, minus 2, 1, 2, minus 1. Okay. Hmm. Okay. Okay. Prefix is correct. Prefix is right. One test case 5, 2, 0, minus 2, 2, minus 1. Segments. One segment begins from like this place and ends here, which is 2, 2, correct? Oh, this is also correct. Shit, this is not correct. Yes. Segment. Shit, yes, this is not correct. I minus 1. That is the place where the last segment began. Yes. But after the last segment began, we saw a 0. So I is a 0. And the next segment begins from I plus 1, I plus 2 in this case. So we should here do minus 2. And here we should increase this by 2 and one test case, five numbers: 2, 0, minus 2, 2, minus 1. We are getting the right answer now. Oh, okay, shit. We have to remove that one line. Okay, cool. That is cool. Are there some other places where you might be messing up? When did you start coding? 2 years ago, 2023, after college, after school. Mm, yes. And okay, this might just throw in our faces Okay. 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 Uh, what could be wrong? We will not look at the test case on which you got the wrong answer. I'm in my third year right now. My third start of the third year. Uh, Third year started a few months ago. Our solution is like kind of right, but not completely. Wrong answer. Yes, fifth sem. On test case 14 is crazy. Shit. Is it a long error? Integer overflow? Or some other thing? Wrong answer. Wrong answer is crazy. Wrong answer. Best. Best is also a long. I think we can look at the test case. Check for overflows. Yes, I think overflows are fine here because oh yes, answer is yes, overflow. Overflow. Shit. Because we will have like a lot of elements. Yes, the mistake is in overflow. And shit. Shit, we have to change our whole approach. Our prefix vector is going to have the number of twos because two is only is shit. Our array could be very big and we could have like just twos in there and that would become very big. So instead of multiplying all the numbers, we do know we can just count the number of twos that we have seen in a range, and that would be nice. Where we have to change our whole implementation of the code, and I don't think I have the energy right now. And yes, I would have to do this later. But yes, the mistake is overflow. Mistake is overflow. We did overflow. Shit. Why did I even went through with this approach? Because there are a lot of elements and we cannot just multiply everything with each other. Instead, we should keep the number of twos, the count of twos and the count of ones that we have seen till this point. And shit, this would have been, yeah. So today we tried to do three questions. We only got one right. I think, yeah, I have to like tone down what I'm doing. And instead of 1600, maybe I should do 1500 rated questions from here. That would be nice. These questions that I've done some few. Yeah, that would be nice because the 1600 rated questions are just taking a lot of time. Yeah, they are taking a lot of time. Yeah, unfortunately, that was it. We were not able to do like even two questions. We only did one question, and that question also took 1 hour and 25 minutes. So yeah, we will have to like go back and solve 1500 rated questions before, and then we will move on to 1600 after some practice. And if we look at the statistics, 1500, there are just 35 questions, I think. And this should be at least 50, and then we can move on to 1600. Okay, okay, that is now decided, kind of. Yeah, 1500. Let's make this 100. Yeah, I will solve 100 questions of 1400 rating and 1500. 1500 rated questions I will be solving on stream, and off stream 1400, and we will get these up to 100 each, and then I'll give my next one test. That would be nice. That would be nice. That would be nice, and that would also be it for today's stream. Yep. And if wait, yes, if there is something on the chat, someone might have to type. They can type now. Yep. And okay, cool. That is the end of today's stream. How much do you study a day? I don't know. One. Yes. How much do you study a day? There is not like a specific limit, but yeah, every day I just feel I'm not doing enough. Like yeah, I think yeah, if you have that feeling, then I don't know. I don't know. You should just study as much as you can, because we do not, as students, I don't think we have anything else to do. You can solve problems on Discord server. VC, I don't know what VC. What is your plan to become a master on code? What is your strategy? Yes, the strategy is from now on to get as much experience as I can and solve at least 10 questions every day. And since there are about 3 months, sorry, a little bit less than 3 months left in the end of the year, I would like to get these 1400 to 22,000 rated questions up to 100, like 100 questions each. And that would be the like question solving part, practice part. And for theory, I have to go through this book completely. Like I should be able to like uh, everything should be very comfortable. I should be comfortable with everything in this book, and all of these things, I'm comfortable with all of these things here. And yes, dynamic programming, greedy algorithm, I would have to do a little bit more reading from other places. Dynamic programming, I'm quite comfortable with at this point. I did I read this chapter today. Range queries, I know about segment trees, binary index trees, and yeah, also sparse tables, static array queries, sparse tables, yes. Bit manipulations, yes, I have gone through that, except this part which uses dynamic programming, bit mask dynamic programming, which is a bit complicated and I don't think I need just yet. And yes, on the side, I'm going through graphs. I've gone through tree algorithms, shortest paths, and both of these chapters. So all of these chapters in the graph section are left. And here I've gone through number theory, combinatorics. I would have to go through them once more. I have to be like really comfortable with them. And all of these things are left, and these two things are left. Yeah, that is the strategy. What is that? Compare rating graph extension. That on the profile. I guess it is CF analysis and code forces helper. We add these two, and these are nice. And this one is bad. Like, remove from rate. The extension which I just removed is adding this thing which I don't even use. Yeah. And did you make any target by this month? Did I reach master? No, I haven't made a target for the month. My whole target is just by the end of the year to reach candidate master. And yeah, and there are daily targets to do 10 questions, which I'm not meeting. No, I'm not meeting the daily target. So yeah, yeah, I'm being a bad human being. Have you solved any DP problems in Code Quiz contest? Yes, there have been DP problems, and yes, you can like go here and look at this. There might be DP 46 DP questions, and there was a DP problem in about blocks in a contest. I was unable to solve it during the contest, but after the contest, I was able to solve it. And yeah, that would be the end of today's stream. If there is anything else, now would be the time. Yo, that is a laugh. Who's laughing? That is nice. Any prior experience with maths? Yes, college and the school, and like I would say maybe I haven't studied maths, but I have thought of myself as a scientist, even though I don't know any like things that a scientist should know, but I have just thought of myself as a scientist. So yeah, I guess general curiosity about maths. Recursive DP. No, I try to write iterative DP. Iterative is better than recursive. Recursive is slower. But yeah, with the recursive you can use memoization, or with iterative you can use tabulation. So when I'm like actually solving a DP question, then what you want is the recursive approach is easier to think about, and then you would have to define your DP state, how you are defining state, and then find a way to fill your DP table in a iterative bottom-up approach. That is how you can do it. How do you think in terms of iterative? And I don't get tabulation technique. I am able to do it with recursive approach. So I would say I was also unable to get it. I just like brute forced my way through it by going through this. In this book, CLRS, Introduction to Algorithms, there is a dynamic programming section here, and this, if you go through this, this is one of the best things you can do if you want to like get really good at dynamic programming. And yeah, this is what I went through, and I think I would have to read this once more because now my DP is much better than when I began reading this chapter. Yeah, I would have to do this once more and also solve CS questions on dynamic programming. CSES, dynamic programming, a few questions are left. 1, 2, 3, 4, 5. Yeah, that would be it. This one, elevator rights, this is one of those bit mask DP questions, and this is tough. Yes, anything else would be nice. Yo, do you have any dream company to get into after becoming candidate master on? No, no, not any company in specific. I just want to get good at things. That is my main goal. And if I'm good, I think I will get a job. That is like what I believe. Naive reality, reality of the naive. Yeah. So yeah, I'm just focusing on getting good. And that I think would be it for today's stream. And thank you for being here. Bye. Yes. Bye.